Hello students, this is the Digital Knowledge Irshad Academy with a new video of voltage transfer characteristics curve. Before going to circuit details, subscribe my channel, press bell icon so that next video reaches you. Now looking at the circuit diagram is a voltage transfer characteristics curve of operational amplifier. Horizontal axis called x-axis. The V input voltage is shown on the horizontal axis in a positive direction, and the operational amplifier is operating in a differential mode, and the indicates a negative input voltage. Vertical axis called y-axis shows output voltage in a positive direction, shows negative output voltage in a negative direction. Coming to circuit explanation, see that when the input voltage is in a positive direction, increasing in a positive direction, the output voltage increases in a positive direction. Start from 0, we increase the input voltage at this point. The output voltage rises from 0 to this value, further increases to second dotted lines. The output increases to this point. Further increase in input voltage causes output voltage to increase. And this, if you increase further input voltage V1, the output is going to increase, but the increase is up to only point X. When it reaches point X, it ceases to further rise, or it becomes a constant. Output voltage becomes a constant. It stops rising when you are increasing the input voltage, or we say that saturation has occurred. This is called positive saturation, and this voltage represents a positive saturation voltage, and it is slightly less than the VCC of the operation amplifier. And this of course is a linear portion from this point to this point. The operation amplifier should operate in the linear portion, and similarly this was in the positive direction and this is in the negative direction. From 0, when the input voltage increases in the negative direction, means when the operational amplifier is working as the inverting amplifier, input 1 is 0. When you increase input voltage, the output voltage rises to this value. Further increase, second dotted lines, output voltage has increased. Further increased up to third dotted lines, the output voltage has further increased, but only up to point X. Beyond point X, negative saturation occurs, and if you increase V input 1, it is output voltage is not going to rise, but it remains constant. And when the saturation occurs, beyond saturation and at saturation, distortion occurs. That will improve with the help of 3 examples. Now these are the specification given. Find output voltage if A is 1000, positive DC supply, negative DC supply, they are 10 volts. V input 1 is 2 millivolt, V input 2 is 1 millivolt. What will be the V naught? Formula V naught is equal to A, V input 1 minus V input 2. We have put the value of V input 1, which is 2 millivolt, minus 1 millivolt, and it becomes 1 millivolt. This can be written as 1 multiplied by 10 to the raised power minus 3. These 3 cancels with this, and you are left with 1 volt. When you are applying 2 millivolt and 1 millivolt in the input, the output is amplified by 1000 times and you get 1 volt. And see that it is in the well below the range of DC power supplies, within the limits, far below the limits, and the operational amplifier will operate satisfactorily. There is no question of saturation. In the second case, V naught is equal to A V input 1 minus V input 2. Let us put the value. A is 1000, gain is 1000 into V input 1 is positive 2 millivolt minus plus 5 millivolt (1000) into 2 millivolt plus minus 5 millivolt, and this is equal to 1000 minus 3 millivolt. We can write this as this. These three zeros cancel with this. We are left with our V naught is equal to minus 3 volt, and the amplifier is working as an inverting amplifier. And see that the DC voltages are 10 volt and output is 3 volt, and in this case no saturation has occurred in positive direction and no saturation has occurred in a negative direction. There is no question of distortion. But in the third example, V out is equal to A V input 1 minus V input 2 is V input 1 is 7 millivolt minus 7 millivolt into 1000 minus is plus 7 millivolt of course this comes out 14 millivolt into 1000, or we say that millivolt cancels with this 1000 and V naught becomes equal to 14 volt. This is contemporary to DC voltages. Why? Because we have DC voltage is 10 volt, but our voltage output is going to exceed point X, that is 14 volt. Now saturation has occurred in positive direction or can occur in a negative direction, and when saturation occurs, in this case when the output voltage is 14 volt, the distortion is going to be produced in the output. Note, V naught cannot exceed beyond 10 volt, correct? Beyond 10 volt, V naught saturates and distortion results. Positive saturation, negative saturation voltage should be less than the DC voltage is V positive, V negative. This point is to be noted, important. Output of op amp can be increased by increasing DC voltages V positive, V negative. However, V positive, V negative cannot increase to indefinite value. Op amp likely to be damaged. That is the limitation of operational amplifier. Coming to the summary. V output is equal to A times V input, where A is a constant factor given by manufacturer in the data book. Can be 1000, can be 10,000, can be 1500. can be any value depending on the design of the operational amplifier. V naught is directly proportional to V input. As V input increases, V naught increases linearly, but as V1 is increased further, V naught does not increase beyond point X. Op amp is saturated. Op amp is also saturated for negative output voltage. Vs positive is a positive saturation voltage. Vs negative is a negative saturation voltage. Vs positive, Vs negative values are slightly smaller than DC power supply voltages V positive, V negative. This point is to be noted. In order to increase positive saturation and negative saturation, then DC power supply voltage V positive, V negative should be increased, but there is a limit to it. We cannot increase DC power supplies. Why? Because if we keep on increasing DC power supplies, the operational amplifier is going to be heated and likely to be damaged. 3 examples we have solved previously, and in the first case is 1 volt tolerable range. The DC voltage is the 10 volt, but our output is 1 volt. In the second case, our output is a -3 volt, again within the range far below the DC power supply voltages, and there is no saturation occurring, and the operational amplifier is not going to heat. In the third case, our output is 14 volt. In case of example 3, V naught is 14 volt and DC power supply is 10 volt. V naught cannot exceed beyond 10 volt. Beyond 10 volt, saturation occurs and results in distortion. However, V naught can be increased by increasing DC power supply voltages, but DC power supply voltage V positive, V negative cannot be increased to indefinite value. Op amp will be damaged, and that is the limitation of black box, that op amp output cannot be greater than V positive, V negative. The point to emphasize or point to note is that the positive saturation and negative saturation should be less than the DC supply voltages. Now, when saturation has occurred in a positive direction and you are going to use that particular amplifier, if you are using it in ideal frequency circuits as preamplifier, ideal amplifier, power amplifier, squelch amplifier, then after saturation is going to produce this distortion in the audio amplifier, in the loudspeaker or APCs. If you are using this operation amplifier as a power amplifier, beyond point X, the distortion will result, and you have to operate within the linear portion of the curve. And if you are using in the radio frequency circuit as the RF amplifier, this particular operation amplifier, if you are using in the RF amplifier as IF amplifier, AM radio broadcast, citizen band radio broadcast, FM radio, in FM radio as IF amplifier, detector, balance modulator or demodulator. PLL is a frequency lock loop, frequency synthesis. In the radio communication as radio telephony or radio telegraphy, and in telecommunication, wherever you use this, and if the linear IC is operating in the linear portion, then there is no question of distortion. But as the limit crosses beyond point X, then the saturation occurs, then is going to produce the distortion, and if the particular linear IC is used in these circuits will result in distortion only when the saturation has occurred. And if you are using in the TV circuit as in the sound system as a video amplifier IF amplifier, as a monolithic or chroma IF amplifier, color demodulator, red, green, blue matrix preamplifier, and it is operating beyond point X, then is going to produce distortion. Any linear IC operating anywhere, whether in these circuits or in these circuits or in these circuits, if it is operating within the linear curve, there is no question of saturation and no question of distortion. The moment it crosses point X, enters into a saturation region, positive saturation or negative saturation will result in a distortion that is undesirable. That's all. In the next video, we'll discuss common mode rejection ratio. Thank you very much.